Okay. So now in this class, let us do the programming about how to draw a line using Bresenham's line drawing algorithm for m greater than equal to 1. Now, if you refer to my YouTube video for the Bresenham's line drawing algorithm for m greater or equal to 1, you can get the theory part or the algorithm section. From that algorithm only, line by line, I will be doing this. Okay. So let us start. Okay, now I have shared my screen. Okay. Okay, so this was my last program, right? So I'm deleting this part section. Fine. So my program is program to draw a line using Bresenham's line drawing algorithm for the value of m greater or equal to 1, right? This program. Now, the algorithm was the first step was read the line endpoints x1, y1 and x2, y2. So, same concept. I will use a printf statement where I have written that enter the two coordinates of the enter the two coordinates of the line. Fine. There should be an accompanying scanf statement as well, where the two coordinates will have four values x1, y1, x2, y2. So, four format specifiers will be there. Huh? And accompanying ampersand x1, y1, x2, y2, right? Okay, the four values, semicolon. Now, since I have used these terms, I will be declaring these terms as well. Int x1, y1, x2, and y2. Fine. The next line says that calculate the value of del x and del y, right? So my dx, my dx is equal to x2 minus x1, dy is equal to y2 minus y1. Since I have defined dx and dy, I should declare dx and dy. I have d. Fine. So I have calculated the values of del x and del y. Del x, I cannot using the triangle symbol, right? So I am using the term dx. You can use any variable name. You can use a, b, c, d, anything you want. My third statement was, or the third step was, initialize the starting point x equal to x1 and y equal to y1. So my starting point will be x equal to x1 and y will be equal to y1, right? And since I have used the terms x and y, I will define them also first time. I am defining. Fine. My fifth step was if del y is greater than del x, then exchange the values of del x and del y and set the exchange variable to be 1. Else, the exchange variable will be 0. So, if the value of del y, that is dy, is greater than dx, then I need to do certain steps. What was my step? My step was exchange the value of del x and del y. Now, exchange values means swapping two values, right? So the simplest was to use a third variable and to swap the values, right? So what will be my thing? Suppose I am using our third variable t. First in t I will save dy, then in dy I will save dx, then in dx I will save t. So by the end of this, I will get the swapped values. That is now dx value will have gone to dy and dy value has gone to dx. And since I have used this term t, so I need to define it also. Fine. It says that exchange the values of dx and dy, which we have done, and set the exchange variable to be 1. So this variable I have set to 1. Else set the exchange variable to 0. Right? So, since I have used another variable, I need to define it as well. So, see, I have defined this. So, whatever variable or new variables you are using, you are always going to define that. Otherwise, you know that in C, right? It will give you an error. So, the sixth step says we need to calculate the decision parameter. So, the decision parameter, initial decision parameter is 2 into dy minus dx, right? And since I have used the term e, I need to define e as well, right? Fine. The next step was I equal to 1. Since I have used I need to define it also. The algorithm or the lines of codes which I am writing, those are just the algorithm step by step. I am just writing it in the format of C. So please see the algorithm. If you have the algorithm, you will get to know what I am writing and what are the formulas I am writing. Then it says plot xy, that is put pixel x, y, and with a color, say blue. Plot means put pixel in this language. Then there is a while loop. In that while loop, there is that the decision parameter, we need to check a condition that whether the decision parameter's value is greater than or equal to 0 or lesser than 0. If it is greater than or equal to 0, we will perform certain conditions, and if it is not this case, a separate set of lines will be executed. So while our decision parameter's value is greater than or equal to 0, what did we use to perform? Then we check that if our exchange variable's value is equal to 1, then our x value will be x plus 1, right? Else our y value will be y plus 1, right? And in any of the cases, the decision parameter will be updated, that is e is equal to e minus 2 into dx, right? This was the set of conditions which was followed. Then there was another thing. If exchange variable value is equal to 1, then y was equal to y plus 1, else x was equal to x plus 1, right? And in either of the cases, e was updated, 2 into dy, right? The next step was I equal to I plus 1, right? And this step was going on if I is lesser than equal to x. So while I was lesser than or equal to x, this entire step was going on, right? So this was the program, right? And what will be my output? Let us execute it. Okay. So same in this screen, enter the two coordinates of the line. I am providing the two coordinates, that is one is 100, 200, x1, y1, and x2, y2 is 200, 300, right? And if I move to this screen, I will get the output. Sorry, it is not responding. Wait for a second. I will do it once more. See, actually, a problem is happening in this Zoom platform, but it just showed the blue line has been drawn between 100, 200, and 200, 300. See, this white section is coming. Anyways, so if you put in enter these two coordinates, you will get the two lines, that is the line that is drawn between 100, 200 and 200, 300. Okay. So this was all about how to draw a line using Bresenham's line drawing algorithm for the value of m greater than equal to 1. Okay. Thank you so much.